Hi, this video is a demo of a custom Metahuman NPC. I built this character in about 2 weeks from concept to implementation in game. Working on it in 2024 for a game I was building. That game's now on ice. But I wanted to dig this back up and show what I did to get Metahuman working for what you would see in a typical video game NPC, because it's not quite automatic. For some background, I used to work at Bethesda Game Studios, so I have a lot of experience setting up characters to be NPCs with dialogue and things like that, and Metahuman is a big step up compared to what I'm used to, and it's also really easy to get all these things done, but it's not automatic. So the Metahuman system is built for all kinds of uses, for characters for all kinds of applications, and it's not really built for optimized video game characters out of the box. That's why Epic had to do a bunch of work to get Metahumans working for UE5, the Unreal editor for Fortnite. They put out a great talk about the work they did there, if you want to watch that. And they've also, more recently in 5.6, added assembly pipelines so that it's easier to get your character optimized for the platform that you're targeting. I did this before that was out, and some of the steps I did here might not be necessary, but I still think it's going to be useful to see how I solved some of these issues. Because ultimately, if you want to make a video game with metahumans, you're going to need to optimize as much as possible. Going back to a year ago to when I was working on this, here are the issues that I ran into. Number one, the head was detaching with animations produced in Metahuman Animator. And to me, Metahuman Animator is the best part of the whole package. And so if you want to be able to use those animations straight out of Metahuman Animator, you don't want your head to come off your characters. Number two, game-ready materials. Number three, game-ready meshes. Number four, wrinkle maps for a custom character. And number five, adding eye gaze, blinks, saccades, and other things that add life to the character when they're not in the middle of dialogue or doing anything else. They're just kind of standing around. You want to keep the face alive. And so how do you do that? If you can do all of these things, then you can get a character that will look at you when you approach, blink, act naturally, and then you can blend in dialogue animations to the face when you want to, seamlessly, and you can blend in generic or custom hand gestures, upper body gestures, and all of that will work with whatever the character happens to be doing, whether they're walking, standing, sitting, whatever. Let's start with a little tour of the character so you know where I am when I'm showing you things. This is the blueprint actor I have for NPCs. It's got our body mesh, our face mesh. Our body mesh has an animation blueprint, and our face mesh has a different animation blueprint. The face mesh is attached to the body mesh. These all came in from Metahuman, and I just edited them. So let's start with a big common issue. The head detaching from the body when you play animations from Metahuman Animator. You can see like she's trying to pull her head forwards and up. That's because it's where her head used to be before she sat down. This character's also trying to put her head back in position where the default should be, and that's because Metahuman Animator, when you want translation on the keys, it keeps that position and it tries to apply it with inverse kinematics. So this is a really common problem that you see online. There's lots of tutorials on how to fix it, but they're all for cinematics, not for gameplay. So before I show you how to fix it, here is a quick overview of the animation blueprint for the face. Mine's slightly modified from the default one you get with Metahuman. So here we have our output pose. This is the body animation and the face animation combined. That is coming in, the body animation is coming in from the mesh and cache pose from attached parent. You remember that the face is attached to the body. So this way we can come in, we can cache this to body pose, we can pass the body pose through a blend into our output. And what's it blending? It's blending the face on top. And so I'll go back to the beginning of that to show you what's happening. And a lot of this, like I said, is from the default Metahuman animation blueprint. So here we've got that same body pose coming in, and this is for some other work that I'll show you later. We're adding our default slot face animations here. And then here's where we're gonna fix the head. So like I said, it's trying to use IK to position the head. We don't want that. We want to turn that off. And so by adding a modify curve node here, you can go in, add a curve pin, and we want to find head control switch, set that to 0, and now your head won't detach from the body. And here's what that looks like. So same facial animation playing, straight out of Metahuman Animator, and now the head stays where you want it. So We turn off the head IK to keep the head attached, but we're then going to lose all animation from the head. So what we're going to do is we're going to add that back in. And there might be other ways to do this. This is the way I found that works. We're going to get curve values from the head animation for yaw, pitch, and roll, make a rotator, and set that on the bone directly. So we're not doing curves like you normally would for Metahuman facial animation. That's because the way this works usually is it goes through to rig logic, which applies all this animation no matter what your head looks like in Metahuman. Usually you modify those curves, it's going to do it right. But here we're just going to rotate the head bone. And we're applying that rotation. We have to go to component space, back to local, and this will get a little bit of head movement back on your character. So you can see the subtle head movement on the character while they're talking. It adds a little bit of emphasis to what they're saying. And it adds a little bit of naturalism back into the performance. Next, game-ready materials. The materials that come with Metahuman are very complex and have lots of features because the designers don't really know what you're going to use the character for. And this offers a lot of flexibility, but it means they're not necessarily well optimized for one specific game. So it's good to keep the material features that you need and get rid of the rest. You can do this by copying the material and then start to remove the things that you don't need. So here's the original Metahuman face material that was outputted from Metahuman Creator. And here's my optimized version. For my purposes, I'm doing a stylized character. I don't need all the complexity. One thing that I found very useful to keep is the wrinkle maps. So based on the face pose, Metahuman will blend in normal maps and diffuse maps and even do a little AO to accentuate those expressions. And it's really good at helping natural expressions pop. So there's a material function here that they use for that. And I'm doing the same thing for normals, and AO takes the normals and applies that wrinkling to the AO. And this is straight from their material, I think. So the way you do this, you just copy the material, you remove nodes, and as long as you're still getting the look that you want, it's going to improve performance. So here's my base color texture. This is hand painted for my character. And then the wrinkle maps, the differences are subtle, but they do matter. I didn't hand paint these. I extracted the wrinkles from other Metahuman textures and applied them here. And I'll show you a little bit about how to do that later in the video. Next, game-ready meshes. Metahuman comes with a lot of extra meshes, geometry, grooms that you may not necessarily need or want depending on the style of your game. So you need to think about, how does the player see the character? How close does their camera get? And do these things even show up? Do they matter? Are they visible? And for me, I was making a stylized game, and so I was comfortable with things like, for example, painting on the eyebrows, not having a separate eyelash mesh. Do you need the extra lacrimal fluid around the eyes? Things like that. Some of those meshes are baked into the face mesh. And my guess is, not having used it, that the assembly pipelines will help you simplify things you don't need. But you can also go into your blueprint here and just delete. And as long as you're still getting a good look at the distance that the camera's going to be, you're optimizing. This character is one that I sculpted and painted in Blender and brought it into the Unreal Engine. And if you're interested in doing that sort of a custom character, there's lots of tutorials out there on how to do it. I'm not going to get into that here. If you're interested in how to do that, you want to look for the Mesh to Metahuman workflow. Lots of documentation and video tutorials to help you there. But if you get to this point, you've got your custom character in Unreal and you're using your custom material that we built earlier. But you also want to keep wrinkle maps, which are a great feature of Metahuman. The rig logic system adds wrinkling and creasing to the face based on the expressions, and it adds a lot to the character. I'm going to show you a little bit about how to do that. Now, if you've never worked with normal maps before, you might want to just skip this part. It's not the end of the world if you don't have wrinkle maps. I like them, but if you know how to work with textures and you want to do that, here's how you get started. So you find the material that Metahuman gives you. So when you're doing the Mesh to Metahuman process, you're going to make a Metahuman using their tools that is sort of like close enough to the one that you want to make. And it's going to have material. You open that up and you'll find all the textures in your reference viewer. You're going to find your base color texture, a CM1, CM2, and a CM3. That's for color map 1, 2, and 3. You're also going to have a base normal map, a WM1, 2, and 3. That's your wrinkle map 1, 2, and 3. Browse for them in your content browser, right click, and export. And this is going to give you the ability to save PNG or TGA. So you can load in those textures into your image editor of choice, and I'm going to follow the same process for the color maps and the normal maps here. And if you look, you can see what the wrinkle maps are doing. It's subtle but effective, and there's more impact in the wrinkle maps that are on the normal maps. So the way you do this is you want to find the wrinkles from the Metahuman textures, rip them out, and then put them on your painted texture or your normal map. The way you do that is you're going to use difference layer. So we've got these same textures. Here's our base map, and if you set the wrinkle map to difference, it's really subtle and hard to see, but you can see it's finding what's different. With some adjustments, you can get a black and white mask of what's different. You're going to use that mask to copy and paste just the parts of the wrinkle map that are different, and then you can put that on top of your texture. This is the original copy and paste, and I've done a little modification to blend it in with the colors of my base texture. If you follow that same process for the normal map, you can see how much the wrinkle map is changing on your normal map. And if you're interested in what the originals look like, you can see they have a lot more detail. I'm going for a hand-painted stylized look on my character, so there's not a lot of skin pores in my textures. But you can see that the quality you're going to get if you work from what Metahuman is giving you, and you try to keep it. So then you're just going to save these back out and load them into the material instance that you made from your material. Now we have a blueprint actor that is game ready, with game ready meshes, game ready materials, and we have animation blueprints on the body and the face that allow you to blend any body animation, locomotion, gestures for dialogue with facial animation directly from Metahuman Animator that includes head movement. And Metahuman Animator is perhaps the most powerful part of the Metahuman system. It allows you to produce high quality facial animation on zero budget using just a phone, and it gives amazingly good results with very little work. But what happens when you're not playing a facial animation from Metahuman Animator? You need to keep your character's face alive. And so the final steps I took here were to work with the eyes, so that when you approach, the character's gaze shifts to you and tracks you. There's subtle eye movements called saccades. You get blinks, and when the character's disengaging and engaging their gaze, there's another blink. And all of this will blend on top of whatever the rest of the character is doing. Eye gaze is what I call it when the character looks at the player and tracks their movement with their eyes. You can also have head tracking, which is turning the head to look at the player, and you could do the same approach here used for the eyes on the head bone, and you'd have head tracking. The idea is you want to have a cone where beyond that you're going to stop tracking and you're going to return to neutral. It's the same with the eyes. If the player exits that cone, you return to some neutral position. So we're going to continue from where we left off in the face animation blueprint. If you remember, we turned off the head IK to keep the head from detaching, and we added back in rotation to the head bone. The mouth close section here comes from the default Metahuman animation blueprint, and here's where we are with eye gaze tracking. So we're going to modify the curves of the Metahuman controls, and what these are, the L and the R are for left eye and right eye. And so you've got controls for look up, look down, left, and right. And the reason we want to use these controls is because they not only move the eye bones and the eyeballs, but they allow the eyelids to follow, which is what you want. Looks much better, and this is a simple way of doing it. You just need to get these float values in the range that these controls expect. And so in order to feed that into our animation blueprint, we're going to do some work in our NPC blueprint. So here on tick, we're going to do our saccades, which I'll talk about a little bit later. That's again just changing the target that you're looking at. It's just moving it around a little bit. And so we take that target and we're going to find out if that target is within essentially our cone of vision. Can we look directly at it, or do we need to look at a default location instead? And if that's the case, we're going to calculate that gaze pose separately over here. And so this looks a little bit messy. I'll get into it, but essentially you need to see that this function is outputting those down, up, right, left values, those float values that we needed for our Metahuman controls. And here we're passing them to our animation blueprint and setting them. We're doing this on tick, so every frame we're making sure that the eyes are looking at what we want to look at. Now what's the rest of this? Well, this is just saying if we're inside the cone or not, or inside the periphery. It's just some logic to say, are we going to look at the player? And we do a little extra trick that comes from animation books, which is if you're shifting your gaze, in other words, you're looking at one thing and then you turn to look at another thing, people tend to blink when they do that. So we're adding one of those blink animations on top whenever we shift our gaze. And then there's some work to do with timing on saccades. This whole pattern is repeated again if we happen to be looking at something that's the backup target and not the player. So let's get into this gaze pose function. This looks intimidating. I got this mostly from another tutorial if you want to see this in more detail. But what's happening here is we are passing our target location. We're creating a look at from a point that we've attached between the eyes on our character. You can see that here. Important to note that that red axis is your x-axis and positive. That's what Unreal always uses for look at vectors. And just for future reference, if we are using that backup target, it's just another scene component that's out here on the ground. So if your character's looking at that, they'll appear a little pensive, like, I'm thinking. So going back to our function, we're going to find the look at rotation from our point between the eyes, looking at the target location, whether that's the player or the ground, and we're splitting that rotator. We don't need X because that's our look at rotation. We need the rotation on Y and Z, and we're remapping that from angles and degrees to 0 to 1 ranges that our controls, our metahuman controls, expect. Then we have our testing of whether that remapping fits. So we know which controls are we using. Or if they happen to be looking to the right, we're not going to activate the control to the left. Same thing for up versus down. Then we're clamping our output values from 0 to 1 and taking them out. And I'll scroll down just so you can see all of the graph here. The periphery here that I'm returning is just so that we don't get dithering. It's essentially like if the player is standing still and maybe the idle animation of the character's head is kind of moving subtly, you might get the eyes flicking back and forth. And we don't want that. So we have a little bit of an inside range, which is our inside cone, and then we have a periphery. And so we're not going to activate the gaze until it comes to that inside cone, and we're not going to deactivate the gaze until it leaves that periphery. Okay, now let's talk about the saccades. And if you remember, this is subtle eye movements that add a little bit of life if you can see the eyes moving around a little bit. They just keep them from being still. And if you remember, before we calculate our gaze pose, we're going to give it a target location. So all we need to do is periodically move that target location a little bit. So inside this function, we are taking our current saccade offset, which we're going to change periodically. I'll show you that in a second. And we are adding that to either the player or the backup target, whichever we happen to be looking at. And I was planning on later extending this code to take an arbitrary target and update that with our saccade offset. And here's a separate function that is periodically changing that saccade offset. Now, we're just calling this on begin play, and then we're going to have it call itself again based on a random float in range when it's finished. And so all this is doing is picking at random from this array of saccade offsets that are numbers I typed in and I tuned just by looking at the NPC, looking at the player, seeing what's too much, what's too little. So this is randomly just popping that location around. The only other thing I'm doing is I am changing the scale of that offset based on if the object's far away, close. This just makes it so you don't get the player really close to the NPC and their eyes are swimming around, or vice versa. If they're looking off into the distance, we still want to be able to see those saccades. So we scale them by distance. Back in our animation blueprint, the next step is we're going to add blinks. And couldn't be simpler. We are doing an additive blend. I have a slot for the eyes, and I literally have one animation montage that is 3 keyframes. I'm taking the eye control, or the blink control, down and back up. And this allows me to use a blueprint function to fire an event, blink the eyes, and I am going to fire off that animation. And this allows me to add a blink whenever I want. If I'm changing the gaze or for whatever reason, we can add a blink. And In the future, I might take these additive blinks out if we're playing a dialogue animation, but for the moment, they're playing along with the dialogue animations, and it doesn't look too bad, so I kept them in there. So let's talk for a second about the fact that I'm doing the eye tracking on Tick, and I was potentially going to add in head tracking as well. This is something I was planning on profiling and potentially moving to C++. I think across several characters, if you were doing this, it might give you a slight performance edge to port this to C++, but the plan is always profile it, see how bad it is, and then make that decision. I don't think it would be too hard. There's not a ton of calculation going on here, and it might provide a nice performance boost. And that's what I did for this proof of concept character. It took about 2 weeks from concept to mesh to fully animated character in Unreal, and it convinced me that this was the right way to go for doing a indie scale NPC in Unreal. And I became a big fan of Metahuman in the process. I didn't cover every detail of what I did with this character because most of the workflows are well documented online. But if you're confused about anything I did here, leave a comment and I'd be happy to follow up. Now here's the unfinished first playable of the game I was working on. It's called Proof, and it's a murder mystery sim set in Washington, D.C. Thanks for watching. I hope this was helpful in some way, and stick around if you want to see what I get up to in the future, and have a good one.